On behalf of the entire team at Pavilion, welcome to today's Pavilion launch announcement. This session is being recorded and will be available on demand. As we proceed through today's session, please share any questions you may have in the chat function, and we will address those questions with a live Q&A featuring Pavilion co-founders Sundar Kanthadai, who also serves as our Vice President of Engineering, and VR Satish, our Chief Technology Officer. Also joining us as a presenter and in the Q&A session is Costa, our Chief Field Technology Officer. At this time, it's my pleasure to introduce Amy Love, Pavilion's Chief Marketing Officer.
Thank you. It's indeed our pleasure to welcome each of you to today's launch webinar. Today, we will share with you how Pavilion is revolutionizing next generation and beyond data centers by shattering expectations across the most critical measurements of performance, density, scalability, and flexibility, enabling customers to rethink what's possible. Across organizations, there has been a shift. We live in a world where all applications are now mission critical, and the sheer volume and velocity of data required to meet objectives is massive. And let's not ignore that the variety of data has changed as well. The different types of data, the different ways in which data is generated, and the different locations where the data is sourced are all contributing to data growth at a massive scale. To handle this growth, modern web-scale applications have had to shift to parallel operations in order to handle this universally overwhelming wave of data. To power these parallel applications, processors have become parallel as well. The growth and adoption of GPUs with thousands of cores operating in parallel are replacing CPUs for intensive modern workloads such as AI, ML, deep learning, analytics, high-performance computing, and much more. Frankly, the entire data stack is becoming parallel as it seeks to deliver solutions to organizations that must be able to ingest and process data in ever-increasing frequency and in greater volume from more locations in order to turn that data into actionable information and insights. The winners of this next wave of business and organizational impact will be those that are powered by a data-centric infrastructure consisting of an environment where applications are parallel, where processing is parallel, and where the entire data stack is parallel. A data-centric world leverages data storage to scale without limits, where every type of data is simple to store and manage from a single point, where data is delivered faster than ever before from a high-density platform that easily fits into data centers of every size, whether on-prem, in the cloud, or at the edge. A data-centric world where parallel storage delivers new levels of performance, density, scalability, and flexibility for all. So let's talk about a data-centric world where storage delivers data faster than the speed of light. Today, it is our pleasure to be introducing Pavilion HyperOS 3.0, powering the most performant, dense, scalable, and flexible storage platform in the universe. It's quite a claim, and we'll back it up today in this webinar. Pavilion, shattering expectations today, tomorrow, and beyond. Today, Pavilion will take you on a journey that will kick your storage into hyperdrive as we lead you to a data-defined business center of the future. We've designed something truly radical. It begins with the Pavilion HyperOS 3.0, the operating system powering the most performant, dense, scalable, and flexible storage platform in the universe. Pavilion HyperOS is designed from the ground up and optimized for high-performance enterprise-grade data management ready to fully support the move of code to data. The impact of revolutionizing the way customers gain value and insights from AI, ML, big data, analytics, and HPC workloads is to impact the organization's bottom line and or the organization's directives like never before. That is the future. What does this mean for you and your organization? Well, let's think about 5 things that you and your organization need. First, you need performance. Check. 2, you need operational simplicity, which includes removing operational complexity. Check. 3, you need data resiliency and availability. Check. 4, you need security. And 5, all of this at a cost that's business and organization justified. When you buy traditional storage, you're forced into trade-offs. You're caught needing professional services in order to get your system even set up. And you must invest time and energy just to get the baseline performance needed. Not so with Pavilion. We're fast and tuned out of the box, and we shatter all expectations for performance, density, scalability, and flexibility. And oh, by the way, also for latency, allowing you and your organization to make decisions at the speed of light. With Pavilion HyperOS 3.0 powering the Pavilion HyperParallel Flash Array, customers now have access to the Pavilion HyperParallel Data Platform. This allows customers like you to put your business into hyperdrive today. So what are the analysts saying about the transformation happening in a data-defined world where storage is key to unlocking the potential of data? Let's find out.
Eric Bergner, Research Vice President, Infrastructure Systems, Platform and Technologies Group, IDC, said, Pavilion's unique hyperparallel architecture can simultaneously support native block, file, and object protocols with eye-popping performance density. Able to corral up to 20 CPUs and 72 storage devices in a 4U form factor, the system efficiently delivers extremely high performance and low latency, predictably at scale, providing a highly efficient end-to-end NVMe-based platform suitable for high-performance, cloud-native, as well as traditional workloads that significantly outperforms the competition, with in many cases a 50 to 75% smaller footprint. And here is Mark Stamer, President of Dragon Slayer Consulting, on Pavilion.
Pavilion has been able to achieve industry-leading performance for simultaneous block, file, and object workloads at scale while using standard-based hardware in an incredibly compact form factor. This is truly impressive. What's even more amazing, it's the first in the industry.
And Philippe Nicolas, analyst with Coldago Research, said,
Hi, I'm Philippe Nicolas, analyst with Coldago Research. Disaggregated high-performance NFS and S3 storage, leveraging NVMe over Fabric and RDMA for low latency, will be critical to enterprises as we work to solve big data challenges, as well as edge computing needs with GPU-based systems. With the ability to deliver industry-leading performance, density, and unlimited linear scalability across systems, Pavilion HyperParallel Data Platform resets expectation in the storage category.
It's now my pleasure to introduce my esteemed colleague, known for bridging the technical and customer value chasm, Costa Hasopopoulos, Pavilion's Chief Field Technology Officer. Costa, take it away.
Thank you, Amy. I'm very excited about the opportunity to talk about our Pavilion technology as it stands today and what we're releasing in our new Pavilion HyperOS 3.0. So Pavilion, shattering expectations today, tomorrow, and beyond. We're in our Act 1, which is today. It's our data management for the Pavilion HyperParallel Storage Array, enabling consistent, predictable, scalable, high performance at ultra low latency. This product's been in the market since January of 2018. So this first part of the presentation, I'm going to talk about our product and give you a basic understanding of our product so that when I talk about what we're releasing, you'll get a foundational understanding of the hardware and services that we have today. So let's start with what the market is driving. The market is driving flexibility in people's infrastructure, right? Because the world is evolving. We're now into these scale-out infrastructures from VMware to Hyper-V to the Kubernetes Dockers of the world to scale-out applications that are more of these Gartner Mode 2 apps built on technologies like Spark and NoSQL databases and Splunk and Elasticsearch. All of these are demanding consistent, predictable, scalable high performance at low latency. So that scale-out infrastructure really is becoming hyperparallel. Those scale-out applications are becoming hyperparallel, which is driving those servers to become hyperparallel. Well, shouldn't that storage scale out and be hyperparallel? Well, the answer is yes. You need to be able to start small and grow big. Add capacity and throughput as your business needs dictate, and give you the flexibility to have multiple controllers, multiple storage types, multiple protocols, whether it's InfiniBand or whether it's Ethernet, all giving you that performance of direct attached storage or storage in the servers with all the benefits of shared. So why is Pavilion different? Well, fundamentally, our storage array looks more like a network switch than it does a traditional storage array. And the network switch is the fastest, lowest latency hardware and software solution in any data center. So if we look at this slide, the top picture is our top view. The left picture is our rear view. And as we look at that yellow area, that's the foundation of our platform. Again, we are built more like a switch. So that's our 6.4 terabit PCIe backplane switch, which connects all our devices together. So we were built from the ground up around that, right? And we were built from the ground up to support a rack scale design. Our software and hardware were designed from day one to enable this experience. And it was built from the ground up to support NVMe and NVMe over Fabric. We were one of the pioneers in NVMe over Fabric, and we architected our solution from the ground up again to support hyperparallelism and to support linear scale out. Remember I talk about that. Linear scale out enables that consistent, predictable, scalable, high performance. And as we look at the hardware, I said that central piece of our whole environment is that 6.4 terabit switch, which every single one of our drives, every single one of our controllers natively connects to all devices in the platform. We can have up to 18 to 72 NVMe drives. We can have 2 controllers, 1 line card. Each one of our line cards, those ones on the left with the port, the network ports, really are 2 individual servers or 2 controllers. They're not dual controllers, 2 independent servers or controllers with their own CPU, network, and memory. And each one of those has 200 gig network ports connected to each one of those servers. So we have up to 40 100 gig Ethernet or InfiniBand ports. All this supporting, these controllers can support either block, file, or object, or any combination in between. And again, performance of DAS or direct attached storage with all the benefits of shared. Well, that hardware platform enables a very, very rich Pavilion HyperOS of our current version of our software, which has enabled that flexibility, scale, and performance. Whether that's block, file, or object, the protocols of NVMe over Iraqi or TCP, the Ethernet protocols, NVMe over RDMA, the InfiniBand protocols, or legacy iSCSI. Our file supports NFS v3 and v4, and our object, of course, is S3. A rich set of storage services that are layered underneath all this. Everything from our data protection strategy to snapshots and consistency groups to unique data assurance, thin provision, encryption, and volume expansion, all the things you expect in a typical storage array. Managed by a very easy to use user interface. But we have an API approach first to our software. So our user interface is built upon our API, so you can leverage any one of our reference guides to build your own user interface or scripts or ecosystem integration. We have integrations to everything from CSI driver for Kubernetes to a vCenter plugin to REST APIs to command line interface and everything in between. All supported, enabling this modern hardware, very dense platform. That platform, as I mentioned before, is 4 rack units. And we have over 17 patents that our software is our key special sauce to that hardware. As Satish, one of our founders, says, our software is designed to take unfair advantage of our hardware. So That performance is 20 million IOPS, 120 gigabytes a second read and 90 gigabytes a second write. Well, people ask, what would you do with all that performance? Well, first of all, you may not need all that performance. You have the flexibility to start small. Maybe a couple line cards, which have 2 controllers, and that's 4 million IOPS with some capacity, running block. You may then add some more line cards, adding more performance, right? But using the same capacity. You could add capacity without adding performance. You see the gist. You can independently scale performance and capacity, allowing you to start small and grow big. But again, giving that linear scalability. If you add one controller, you get 1 million IOPS. You add a second controller, you get another 1 million IOPS, because they're independent controllers enable that consistent, predictable, high performance with low latency, whether it's block, file, or object. This platform is one of the most high performance storage platforms in the planet, but ultimately the most flexible. Whether that's density, 4 rack units, not 4 racks, 4 rack units. Today's platform is 1.1 petabytes raw, 20 million IOPS, 20 controllers, and 40 100 gig Ethernet ports. As you look per rack unit, that's a quarter of a petabyte per rack unit and 5 million IOPS and 400 gigabit performance from a network perspective. Any one of those platforms can be supported leveraging block, file, or object as a storage type, leveraging any one of these protocols, whether it's a file, block, or object protocol. Now, that density, leveraging that flexibility of the storage type and storage protocol, enables best in every class performance. As we look at the Olympic things where you have the bronze, silver, and gold, let's look at the podium for each one of those platforms. If we look at block, 120 gigabytes a second read, 20 million IOPS at 100 microsecond latency. Best in class read. But even as impressive is 90 gigabytes a second write. That's just 75% of our read. That's impressive. 5 million IOPS at 25 microsecond latency. Best in class. File, 90 gigabytes a second read, 56 gigabytes a second write. Object, not slow object, fast object, 80 gigabytes a second read, 35 gigabytes a second write. So best in class, best in every class performance. But not just performance, but performance density. And not just performance density, but flexible performance density, all at market competitive pricing. You're not paying a premium for this best-in-class performance. As we look at this Pavilion environment, well, so what with all this performance? Well, what does it do? It gives you that consistent, predictable, scalable high performance and ultra latency in this incredibly dense and flexible platform, all at market competitive price points, enabling your applications to run faster, perform more consistently, and to scale larger. It enables those workloads, everything from AI to machine learning to analytics to high frequency trading and everything in between. If you need high performance, low latency, and high bandwidth, Pavilion is the platform. So Pavilion, shattering expectations today, tomorrow, and beyond. We're in our Act 2 now. Let's talk about tomorrow. We're welcoming you tomorrow, the world of information management, introducing the Pavilion HyperOS version 3.0, running on our current Pavilion HyperParallel Data Platform hardware. And we're powering the most performant, dense, scalable, and flexible storage platform in the universe. So the Pavilion HyperOS 3.0, what is it majorly? It is a multi-chassis global namespace for NFS and S3. We're adding this functionality to everything we do in our current Act 1 platform, all running at faster than the speed of light. We're talking performance that's 150% the performance of the nearest new file and object players that are out there today. Over 400% the performance of the incumbents file and object players out there. So Pavilion HyperOS 3.0 is a game changer in the global namespace multi-chassis environment. So what workloads can travel at this faster than speed of light? Everything from the HPC's environments to data analytics to AI to machine learning and big data in general. But we enable this flexibility of deployment. Again, with that best-in-class performance. We give you that flexibility to bring your own file system. Use our file system. Use our block. Use our object. Leverage protocols from block, as you see, from object, whether those are native S3 protocols or plugins to native applications. Multiple ways to connect to our NFS platform. Everything from NFS RDMA to a Gluster client, to a Spark plugin and a Hadoop plugin and everything in between. Giving you that ultimate flexibility in performance, ultimate flexibility in choice of storage type and protocol. Whether that's one box or a cluster of multiple boxes. So our Pavilion 3.0 HyperOS is that foundational upgrade that really is focusing on file and object and maybe making our already performant file and object be best in class from a global namespace in a cross-chassis platform. But it starts with a new version of a base of our HyperOS storage services, and we're introducing the capability of running containers on every one of our storage servers, each one of those servers. The first two applications that run inside containers are our global namespace for NFS and our global namespace for S3. Building applications, leveraging our platform, that logic says someday in the future, we'll allow other applications to run inside those containers on our platform. Today it's us, tomorrow it may be somebody else. As we look in this platform, each one of these controllers, as I mentioned, has its own independent CPU, memory, network, and operating system instance. So each one of those 20 controllers has a version of its OS running independently, right? Well, so what of that? Well, again, that's how we get our linear performance. We don't have one controller or two controllers. We have up to 20 controllers. We can start small and grow big, have 2, 4, 6, 8. Consistent performance as we scale. Independently run block, file, or objects. Those controllers can work independently or they can work together. An example of working together is our new global namespace, where multiple controllers will work together to share a namespace, whether that's S3 or object or NFS. Another example of that is something to leverage our core storage protection services, doing a RAID rebuild. We can call upon if a drive has a problem and we have to do a RAID rebuild, multiple controllers can be called upon to work together. It's called Swarm. We can actually recover 1 terabyte every 5 minutes. We can recover a 15 terabyte NVMe drive in 75 minutes. So controllers can work independently or work together. So this Pavilion HyperOS version 3 has enhancements to block, has enhancements to our file, and has enhancements to our object. The majority of those enhancements are focused on file and object, but there's some unique things that we've enabled inside our core operating system. One, as I said, was containers, right? Let's talk about that. The other one is enhanced quality of service support. We now allow people to put up to 4 different tiers of quality of service based upon a capacity based of IOPS allowed for a volume. You can set the amount of IOPS that any volume can have so people don't step on each other from a performance perspective. We also provide Ludicrous Mode. You can take as much as the system can give. We're also announcing moving from 1.1 petabyte raw, which we have today, which is about a petabyte usable, moving to 2.2 petabytes raw, which is 2 petabytes usable. And I'm going to talk with a couple slides here about some new high availability enhancements. The first one of those enhancements is because we have multiple controllers, not 2 controllers, and all those controllers are literally connected on our PCIe fabric to every one of our drives, we have the ability to really have more of a round robin type of failover. Failover controller 1 can fail to 2, 2 to 3, 3 to 4, 4 to 4, 4 to 5, and 5 to 6. Typically a way to do that. When you're doing that sort of environment, you have to make the business decision of how much workload I put on any given controller. Because if I put on more than 50% on 2 controllers, then in a failover situation, the workload performance may not be the same. We give you the flexibility to really have a hot standby controller because we have multiple controllers. So down below, Controller 6, 7, 8, and 9 can all fail over to 10 that's just waiting for a situation. Now you may say, well, that's going to cost me more money to have an extra controller. But what if every one of those 4 controllers could run a lot more workload, because you know that when it fails over, if it was running 80% utilization, you'd have 80% utilization again because it's an empty controller. So if you really did the math, you could run every one of your controllers at 80% and you would get actually 30% workload increase over running 5 controllers at 50%. This is really an industry first. One of the only players in the world, because of our multiple controllers, have the ability to have an active standby controller. The second piece is in data assurance. This is in the ability to ensure a checksum and versioning. And this is supports of T10 diff that we've always supported, obviously, which protects against like the bit rot inside of a drive. But there's also, as these drives become bigger and bigger, we're getting to 30 terabyte drives and having lots of performance on these things, there could be a challenge where a write may be dropped physically inside the drive. It has nothing to do with Pavilion or any vendor on the planet, right? A drive can miss a write, 1 in a billion, but it could be a huge problem for the file system running on top of this thing. So we implemented a technology called versioning. This is a patent pending, and it was driven by some use cases from some of our customers. So we have the technology that when we write our data, of course, inside the data on every 4K block that's written on each one of the drives, there's a checksum area. That's how you do the T10 diff and the RAID and the parity, right? We actually have a version in there, in the custom metadata. So when we write each 4K block, we put a version in that. We then take that version number and put it in our metadata. So then when things are read from disk, we make sure the checksum hits out. If not, we rebuild from parity. Also, if the version isn't the same, it means a write was dropped. So we again rebuild from parity. So this is a patent pending from Pavilion, a very unique feature to ensure that we can provide 100% data assurance and confidence from our customers. So what about our high performance file system, whether that's NFS or S3 for our new version 3.0? Think of this platform. You could have a single Pavilion chassis running all NFS. You can have a version running all S3. You could also have a version running a combination of all those together. Ultimate flexibility in a single chassis. But not just a single chassis, we could have multiple Pavilion chassis. Each one of those 4 rack unit chassis could be scaled together in a cluster running a global namespace for NFS or S3, or some combination of NFS and S3. Now that's not just flexibility for S3 and NFS. We can do that flexibility for block, file, or object in general. So a single Pavilion chassis could have some iSCSI, could have some NVMe over Rocky, could have some NFS, and could have some S3, all on the same platform. Remember, those are independent controllers with their own CPU, memory, and NICs, having their own space and performance characteristics. Not just a single chassis, that could be on multiple chassis, right? You could have some S3 crossing chassis, NFS, or an S3 bucket on one, or block, or whatever makes sense. But you can also leverage our NVMe fabric and our block protocols to layer on an external file system like IBM Spectrum Scale, Lustre, or BGFS. Ultimate flexibility in deployment. So as we look at this NFS functionality, it's really the key features of multi-controller. In other words, remember we have 20 controllers in each one of our chassis. So it can span multiple controllers in a chassis, or it can span those controllers across chassis in a shared distributed file system, delivering very high performance, 60 plus gigabytes a second read and 40 gigabytes a second write, with all sorts of flexible connectivity from RDM, NFS RDMA to NFS v3, which are standard protocols, right? No host software required. Or you can run a native client for Gluster on a host to get ultimate performance guarantee. And as we look at Hadoop and Spark plugins native into our system, right into the app to give unique performance right directly to unique apps like Hadoop and Spark. Tiering NFS to NFS inside our box or inside anywhere in one of our clusters, NFS to any other NFS, another vendor's NFS, we can tier to, or we can NFS to any S3 client, replication, security, we have snapshots and clones, all the storage services that you expect, including their encryption, leveraging our base storage services that's part of our overall platform. You can have a single namespace or multi-namespaces. As we look at S3 functionality, similar to NFS, single controller, multi-controller, right? Multi-chassis, in other words, cross-chassis. Again, high performance, single or multiple namespaces, compression, replication. You can access this via S3, of course, because it's S3 functionality, but you can also access it via a file protocol, security profiles through identity management, and you can tier to multiple cloud types. And we have many ultimate ecosystem integration, everything from big data and machine learning applications with native integrations to ecosystem partners all around leveraging our S3 platform. So Pavilion, that most flexible, high performance storage platform. But what's new for 3.0 is now we're announcing 2.2 petabytes raw or 2 petabytes usable. And the new performance with our global namespace for NFS, 60 gigabytes a second read, 40 gigabytes a second write, that same performance for S3. So not just performance density, but flexible performance density, again, at market competitive prices. This upgrade price for our existing customers, as long as they're under maintenance, is a no-charge upgrade from them. If you're a new customer buying our product, you get these features and software all part of the package, no extra costs. So what am I going to do for NFS and block, or that fast NFS and fast block? Those use cases like I talked before, anything from AI to HPC to machine learning. But think about this. Is there many use cases to enable applications like these? Everything from TensorFlow to Greenplum to Hadoop to Spark, all these different types of applications to provide solutions from AI to data analytics to high frequency trading and everything in between, but ultimately delivering cost-effective outcomes to the business, helping applications or your applications run faster, perform more consistently, and scale larger. So we talked about fast NFS and block, which most people understand, but fast object is becoming a requirement, not just for things like Splunk with their smart store, but native applications like Spark and Apache Drill and Elastic all have native software and solutions to store directly to S3 targets. So people are leveraging this to make these cloud native applications, whether they're running them off-prem, which they now want to run them on-prem, we can give them that high performance in the object space. So people ask me a lot about the competition. Well, how do you compare to competitor XYZ? Well, first of all, I was asked to ask, are you talking about block or file or our object, right? But today's announcement is really about our new functionality of S3 and NFS. So let's look at some of the newer file competitors in the market, right? One of these players, 40 gigabytes a second read, 5 gigabytes a second write, about a petabyte. You know, a couple 2U grows in 2U platforms, providing NFS and that. Another player that requires host agents on every one of the clients, right? Again, smallest you could start with is about 2U4 nodes, right? About 4U, about 40 gigabytes a second read, 17 gigabytes a second write. Now introduce Pavilion, right? In this space, NFS, NFS RDMA, S3, and all of our block protocols, 90 gigabytes a second read, 56 gigabytes a second write. With our new global namespace, 60 and 40. So let's compare that to the competition. 1.5 times both of these competitors. From our write perspective, we're 8 times the performance of the guy on the left. We're about 2.5 times the performance the person in the middle. All running on a 4U form factor with over 2 petabytes of raw, 2 petabytes of usable storage. If you compare that to the incumbents that are out there, been around quite a while, our performance is even way more than each one of those, because their performance is more around the 15 gigabytes a second read. Most of them don't publish the write. So the performance and scale is what makes our solution very unique. So as part of this, we asked a favor of all of you. our partners, the analysts, our potential customers, and our existing customers. When you talk to our competitors, and of course us, ask a few more questions when they talk about performance. Don't just ask for their read performance. Ask what their write performance is. Ask what their latency is for read and write is. What is the latency? How are you measuring that? Are you measuring that from the host? Or are you measuring that from the ingress and egress of the box? By the way, our latency, whenever we measure it, is measured at the context of the host through the network to our box and back. So ask about, what is the bandwidth for large block? What is the IOPS for small block? What capacity do you have in what footprint? If you get all these data points, I think you'll find that it's actually relatively easy to do some performance numbers with a lot of hardware. It's also very, very difficult to do it in small form factor, in a 4RU form factor. So in summary, we're very excited about the Pavilion HyperOS 3.0 running faster than the speed of light, and we're powering the most performant, dense, scalable, and flexible storage platform in the universe. So as we're running it faster than the speed of light, give you that ultimate flexibility, whether it's block, file, or object in that 4 rack units, 120 gigabytes for block, 60 gigabytes read for our new global namespace. You can see our regular NFS. You can see the performance that we're getting, leveraging spectrum scale, luster, and numbers coming soon from our BGFS. Now let's take that and put that in a rack. Put 10 of our units in a rack. We're delivering over 1.2 terabytes per second per rack in block with almost a terabyte a second write, 900 gigabytes a second write. In our global namespace, 600 gigabytes a second read, 400 gigabytes a second write. Remember, that's 10 of those boxes. That's 20 petabytes, 200 independent controllers, 400 100 gig Ethernet ports. Very impressive, dense, high performance, ultra low latency. So Pavilion, again, we're running faster than the speed of light, enabling these applications from big data to machine learning to analytics. We make these applications run faster, scale larger, and perform more consistently. So Pavilion, our Act 1 is what we have today, our data management. Our Act 2 is we're welcoming you to tomorrow, today, by the way, is information management. But we're shattering your expectations today, tomorrow, and beyond. Thank you. We look forward to working with you to show how we can help you shatter your expectations. Thank you. Back to you, Amy.
Thank you, Costa, for that detailed perspective, tying together how Pavilion is shattering expectations today, tomorrow, and beyond. Before we dive into our live Q&A, let's hear from a few Pavilion customers and partners in terms of their experiences with the Pavilion team and products.
Kamal Bakshi, director at Cisco, said, Cisco's ACI fabric with zero trust security and advanced traffic congestion control methods is a perfect fit for NVMe storage over Ethernet. At Cisco's NVMe Research and Testing Lab, we have been using Pavilion HyperParallel flash arrays to test tens of millions of storage IOPS over NVMe TCP sessions with Cisco UCS servers. The ability to change protocols with the click of a button delivers unrivaled ease of use. The Pavilion HyperParallel Data Platform with multi-controller support, flexibility, ease of use and management sets the industry performance standard for NVMe data storage. And here is Kevin Tubbs with Penguin Computing.
The Pavilion HyperOS enables us to create massive rack scale deployments with over 15 petabytes of capacity and up to 1.2 terabytes per second of throughput per rack.
And the Meadowgate team said, the Pavilion team has enabled us to deliver unprecedented performance to our very demanding data analytics customers. Their solutions and support are world-class. Billy Russell, Vice President and CTO at Alliance Integrated Technology, said, the Pavilion platform delivers the performance to meet the needs of the next generation of high-performance workflows across multiple workloads. The raw performance, density, multi-tenancy, and protocol support that Pavilion delivers is in a class we have not seen in any other flash storage platforms. Our joint customers can cut production time, utilize the storage more efficiently, and accelerate production workflows, all of which have a material impact on M&E profitability, while also helping them future-proof their infrastructure. By adding the ability to tier into an NVMe pool, as well as being the only vendor to support NVMe OF on Windows, Pavilion is leading the way.
I hope it's clear now why we say Pavilion, shattering expectations today, tomorrow, and beyond. So let's move to our Q&A featuring Pavilion co-founders Sundar Kanthadai and VR Satish, as well as Field CTO Costa Hasapopoulos.
Wonderful. Well, I want to remind everyone, if you have any questions, please feel free to use the chat function in order to ensure that we have the opportunity to address your questions. We're going to go ahead and kick off immediately by throwing a question out to Sundar. Sundar, a question that's come in is, how do your engineers work with customers to ensure the best case performances that Costa talked about become real performance at deployment?
Thanks, Amy, for the question. We built a lot of custom test suites that we run against every product release we do. We're constantly improving these test suites as well as we encounter new test cases and new customer deployments. But fundamentally, we have a cashless design, and we don't have to tune for any specific workloads. Our numbers that are published and the one that Costa shared are right out of the box without any specific tuning. And the results that we share are the ones that the customer would expect to see in their applications.
Great, thank you so much for that, Sundar. Satish, a question that's come in is, what made you all, you and Sundar and the early pioneers within Pavilion, what helped you all decide how to build the company's technology based upon a switch architecture?
Thank you for the question, Amy. Well, our goal was to build a device for today, tomorrow, and beyond. Right? What we recognized was there's a tremendous amount of increase in data sizes. The demand for speed required us to think completely out of the box. As media was approaching memory speeds, we're seeing that with storage class memory and NVRAMs and all that. And as networks reach very high speeds, we need an architecture that can move data between the network and the media almost at a line rate at the speeds that the networks are delivering. Just a couple of days back, we saw an announcement from NVIDIA around 400 gigabit Ethernet cards. Now, this is what we're dealing with today. So look at what's going to happen tomorrow. So this led us to say, why don't we borrow some of the architectural principles that are so successfully being used in the networking world, because they figured out how to do this at performant and scale, and take some of those principles and apply to storage. It's not one-to-one. Obviously, storage has its own characteristics. So when we put together this box with those design principles, we hit our mark. Our goal was to hit a terabit per second in our box. And we actually achieved it on just the prototype. So we were very bullish about what we had done, and it proved that our design approach was right on the money.
Great, thank you for that. I think people have really brought that question up on many occasions. I'm very glad it got asked today in this webinar for people to really understand the reasoning behind and the forethought that is coming to fruition. It's the reason why it's built on the switch architecture. So thank you for that very much. Costa, question for you. They want to know, you talked about customer choice and control in your presentation. And move beyond the marketing term of what that means. They want to know, how does that really play out in a deployment? What does it really mean for customers to have choice and control?
That's a really good question, and I think it goes back. I'll just tie the one marketing thing in because the answer is, as Satish says, today, tomorrow, and beyond. One of the challenges that we see our customers and partners out there is, you know what you need today, but you don't need what you need tomorrow. So today you may need a bunch of block. Tomorrow you may need some file. and the next day you may need some object or something in between. So by having a single platform that's really best in class in each of those three categories, it gives you ultimate flexibility without having a platform for block, a platform for file, and a platform for object. Then all of a sudden now you start having wasted space and wasted capacity and things like that. So ultimately our architecture can enable that flexibility and choice for the customer.
Great, thank you. And I see more and more questions coming in on the chat side, so just want to continue to encourage people to go ahead and post those questions, and we'll bring those in. Sundar, another one that has come up for you. Are there limitations we should be aware of, the viewers today want to know, regarding what the Pavilion HyperOS and or the Pavilion HyperParallel Flash Array platform are capable of handling?
Yeah, good question, Amy. The product is built for providing maximum flexibility for block, file, and objects, and provides the linear scalability and performance across various protocols. Our roadmap is aligned for specific use cases that we are going after, and our performance density can address. More specifically, we are not going after user-generated content like home directories. We are going after machine-generated high-velocity data. Right? That's the focus for the release.
All right, fabulous. So Costa, here's a question for you. Costa, the question for you is the 3.0 OS capable of handling Kubernetes deployments out of the box?
They actually are. We don't even have to wait for 3.0. We already have a CSI driver for Kubernetes in our platform today. So the answer is yes today and yes for 3.0. And I see Sundar and Satish both shaking their heads. So.
Sundar or Satish, anything you'd like to add on to that answer?
I think we were the first ones to do a CSI driver for NVMe over Fabric, and we have deployments out there with Kubernetes CSI driver. So real world use case there. So.
Great. All right. Thank you. Satish, next question for you. How do you intend to move faster than the limitations of existing hardware and networks?
Well, if you look at our goal, we wanted to start off with data, right? The ability to store and retrieve data fast. That was our act one. The second one, and it was all dealing with blocks mainly. The second one was to transform that, move one step ahead, and move that to deal with information. So today we launched, the global namespace and object storage, so we get context of the data. And we have enough controllers there so that we can, do more with it. The third phase beyond is about inference and intelligence, which is even further, right? I mean, at the end of the day, customers want that. And to get to all the way to intelligence, we purposely, by design, by execution design, we split up into 3 acts, 1, 2, and 3. Now, you have to understand that you cannot bend the laws of physics. I mean, the physics is physics. You can't go faster than that. But, to draw an analogy to what we have seen in our own industry, that is storage industry, is people said that you can actually store more data than what the media can allow you to store. A classic example of that was to use out-of-the-box thinking with respect to software. They provided deduplication, and they said, if you don't write the data, and you can still fetch the data because you threw away the duplicates, you can get what you want. So you can actually store, 8K and a 4K if the two 4Ks are duplicate. Now, this is all about bending, going beyond physics here to use out-of-the-box thinking and provide that. If you look at the case of what we're doing in Pavilion, at the end of the day, you want to get your information, get your answers as fast as you can. And our architecture allows you to move code to data. Think about it, if you have to read a petabyte of data to get your answers, what if you prevented reading the petabyte of data and moved code to data so that you can analyze the data right in there? So an IO saved is an IO gained. Net, you actually did a petabyte per second if you could just move a small bit of code in a second. So it's more a logical concept. I mean, we are going to be traveling faster than the speed of light, and figuratively speaking, because we are going beyond what physics enables us to do.
Great, thank you so much for that, Satish. It's interesting, you know, we've been asked that question, and a version of it came up today when people say, so what does it really mean to be traveling faster than the speed of light? Well, it really does revolve around Pavilion's commitment to customers that they can shatter expectations. There's, you know, absolutely this perception that you can't travel faster than the speed of light, that it isn't possible. Yet, as Satish was just talking about, and as many scientists have said, they actually believe it is. We just haven't seen it yet. So if you think about that in terms of today's environment, people actually thought you couldn't have best-in-class performance for block, file, and object with unlimited scale, yet you can with Pavilion. Costa had the chance to share that and demonstrate that in his presentation. People also thought you couldn't reach 1.2 terabytes per second per rack throughput with a latency of sub 25 microseconds. Yet you can with Pavilion. So when we talk about much like traveling faster than the speed of light, Pavilion offers what many thought was impossible. And that's in part what we've hoped that we've been able to share and bring out in today's presentation. And we have a few more specific questions that have come across that I want to continue on. But in saying that, it's really why we say Pavilion, shattering expectations today, tomorrow, and beyond, and making the impossible possible. That's why our customers say that about Pavilion. Because at the end of the day, this is about customers and what each of you can do with the right hardware, software, the right platform that allows you to achieve your goals and your objectives. So with that, Costa, a question that has come up is, let's talk specifically about what's involved with moving or assigning data LUNs based upon block, file, and object workload needs. Because you talked about choice and control. We've just talked about what it means to have best in class for all three. What's involved with the migration and movement?
Yeah, you have to speak of those in each one of the protocols of block, file, and object. And I'll speak of it in block as we have customers today, and we've talked about supporting iSCSI from a legacy protocol. They may not be ready to move to NVMe over Fabric or whatever it happens to be for block, so they can create volumes on our system, controllers that support iSCSI and have their hosts connected to iSCSI and be running that VMware environment, that extra app, whatever application it happens to be. And when their journey and their time is right, they may choose to move to NVMe over Fabric TCP. And all that simply does is require a reboot of the controller on our platform. And the controller now serves up that same LUN, no data migration, no change of the data to NVMe over TCP. Do that same thing for NVMe over Fabric Rocky. So we can just natively do that. Of course, depending on the operating systems from the host, they may require reboot or rescan or whatever, but that's an operating system issue. But that's a start in one platform, move to the next, that ultimate flexibility. But you moving from block to file, from file to object, that is not a technology that is out there for actually anybody to be able to do that. Those are all data migrations, unfortunately. But you're in block mode, iSCSI, NVMe TCP, NVMe Rocky, boom, 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 no data migrations. Again, ultimate flexibility.
Great, that is definitely customer choice and control. Thank you, Costa. Sundar, questions come in. How is Pavilion able to deliver the performance when we see other providers running into significant limitations? Now, in essence, what's the magic for Pavilion?
Good question, Amy. Our system is built ground up for performance. This includes the hardware and the software that's tailored to run on it. We have special IP that's built in to provide very low latency metadata read and write accesses that even storage class memory like Optane couldn't match. I think that gives us an unfair advantage for our software to take advantage of our hardware to drive that performance all the way to the applications.
Great, and the edge is certainly a topic that comes up often. Satish, a question that came in is, in the presentation, We spoke a bit about having unlimited scale. Let's see, it says being at the edge, but it isn't the edge, all about shrinking footprint, not scaling up. The question is that a contradiction? Can you address that question for our audience?
So the edge is an overused term today. People like to use buzzwords. There's a little bit of unknown. What does the edge mean? The edge can be really small in terms of micro edges, which you put for IoT devices here and there. Or it can be enterprise edge, which could be a little larger, but still, data centers in general are themselves getting disaggregated.
Can you send Costa a comment?
They're themselves getting disaggregated, and they're spreading out, and they're moving closer and closer to edge deployment so that people can take advantage of the benefits that are given by cloud service providers. So people are using this technology for caching data. They're using this technology for streaming data to the cloud, staging it in streaming. They're using technology for improving the signal to noise ratio so that you don't have to, send so much data over to your data centers and all that. Now, when you're looking at edge, it can't be a big data center at the end of the day. You have to be very cognizant about the fact that you're probably going to be in some colo location, somewhere out in the remote site. Could be in an OB van. It could be in a movie production area. So it needs to be portable to as much as you can. So it has to be small as it's physically possible. So density, performance density is very, very important in these cases. For some edges, we may not even be suitable, just to be fair. I'm not going to say that we're suitable for every edge that is out there. What if you just want really a small micro edge? So there are other platforms that can do, software-defined things that can do it. For areas where you need high throughput, low latency at the edge, we have a fantastic platform because we can deliver the kind of speeds at the form factor that is completely unheard of. Hopefully I answered the question.
I think you did. Thank you so much. Costa, 30 seconds or less, given your presentation, what would you like to have as the lasting thought from your standpoint out to our audience today?
We keep using that word flexibility and choice, but I can't overstate that. We've a lot of us, on the phone and here have been in the industry a long time. And one of the biggest challenges with storage is storage has become the bottleneck again, especially when we get into AI and machine learning workloads. So you need high performance and low latency. That's one use case. The second piece is, again, with that flexibility and choices, don't paint yourself into a corner with one particular protocol and then have to buy another storage array. Remember, with our platform, you could start with 2 little line cards and move to 10. 2 controllers to 20 controllers gives you that ultimate flexibility and choice. So make sure and drive that efficiencies as much as possible.
Great. Thank you so much. Well, 2 points I want to make here. First and foremost, thank you all so much for joining us today, for taking the time to learn more about Pavilion HyperOS, and about the Pavilion HyperParallel Data Platform, and how and why we say traveling faster than the speed of light is now possible. With Pavilion data, you get the highest performance, density, scalability, and flexibility in the industry. I would like to encourage each of you to take a look at pavilion.io, request an SE discussion on a technical level or an AE discussion on a business level. Let us know what your issues and challenges are. We are here to help you shatter your own expectations so that we can show you making the impossible possible can happen. In addition to that, and follow up with this meeting, sometimes Zoom doesn't play out as high of quality on the video stream as desired. So for those of you all that have registered for this webinar, we will send you a limited time link so that you can get the full high definition of this video to review. And then we will also have the opportunity for those that have not yet registered to register to get access to our presentation as well. Again, on behalf of everyone at Team Pavilion, it's our pleasure to say thank you so much for being part of today. And most importantly, we look forward to being part of your future and what you're seeking to accomplish in your organization. Thank you so much and have a wonderful day. Bye-bye.
Thank you.